Hi, welcome to Elasticity. Today we are going to talk about constitutive relations for a linearized elastic solid. So if you remember, we needed, so let's get that down, we needed 6 additional relations to round out our equations. Okay, so where do we get these 6 additional relations? So a linearized elastic material so let us make it more general than that. A linearized thermoelastic material is one in which the linearized stream is a linear function of the stress components and the temperature. What I mean by that is the strain epsilon should be f of stress comma theta, and it has to be linear in stress and linear in temperature measured from some reference temperature. Now I want you to understand something. You might think that means that epsilon equal to A times sigma plus B times theta. That's not correct. This is wrong because epsilon is a matrix, this is a matrix, and this is a scalar, so there are all kinds of problems. So we are going to have to do it a little bit more carefully. What it means is that I have to have each component of epsilon. So let us say I got epsilon 1, 1. That should be linear in all the stress components and the temperature. Same for the others. So what does it mean? It means that epsilon 1, 1 should look like C11 sigma 11 plus C12 sigma 12 plus C13 sigma 13 plus C22 sigma 22 plus C23 sigma 23 plus C33 sigma 33 plus A times theta. Notice it has 1, 2, 3, 4, 5, 6 and a 7 constants in it for each of them, and each component has new constants. So that's what we mean by linear. So I want you to understand this is not a simple thing. So let us write it down. So we are going to write it in index notation. You can see where we use the index notation, and also matrix notation. The reason for using matrix notation is that the picture will help us think about it. So index notation looks like this: linearized thermoelastic material looks like epsilon ij equals C I J K L. Sorry, we are not going to use C, we are going to put S ijkl sigma kl plus alpha ij theta minus theta naught. This is coefficient of thermal expansion. This is temperature. This is stress. And this is a compliance matrix. Okay, so this Sijkl, how many terms will it have? Sijkl must have 3 times 3 times 3 times 3, which is equal to 81 terms. Not all are independent. Why are they not all independent? That's because epsilon ij equals epsilon ji and sigma ij equals sigma ji. So if I really write it down, I'm going to write it down in matrix notation. You will see. I'm going to write it as epsilon 1 1, epsilon 2 2, epsilon 2 3, epsilon 1 2 twice, 2 times epsilon 1 3, 2 times epsilon 2 3. Sorry, I will write it in a slightly different way. I mean, there is a reason for doing that, so I'm going to write it in a particular way. 2 3 1 3 1 2. Okay, so I'm going to write this as a single row. And why all these 2's? Because these are actually gamma 2 3, gamma 1 3, gamma 1 2. This is the shear strain. Okay, so this must be equal to, now comes our big matrix. There are lots of terms, so I'm making plenty of space. And here I'm going to write the stresses: sigma 1 1, sigma 2 2, sigma 3 3, sigma 2 3, sigma 1 3, sigma 1 2. And the call of the rows here will be C11 11, sorry, S1122, S1133, S11 let's see, 23, S1113, S1112. Then I'll have S2211, S2222, S2223, sorry 33, S2223, S2213, S2212. You get the pattern, right? Then the last one, S3311, S3322, S3333, S3323, S3313, S3312. I'm going to draw a line here for a particular reason, because you will see that the different blocks have meaning. So I'm just going to put dot dot here. This is, I'm going to say, symmetric. That has to do with this condition and this condition. And then I will have S2323, S2313, S2312, then S1323, S1313, S1312, then S1323, sorry, 1223, S12, let's see, 13, S1212. Jeez, that's a lot of terms. But the nice thing is, so there are 1, 2, 3, 4, 5, 6 terms here, and there are 6 by 6. So this is a 36 term matrix. We will simplify it further. So let me not at this stage, let's not even say that this is symmetric. We don't need it right now. So this has, I'm going to write everything down, what the heck. So this is S11, let's see, sorry, S1311, S1322, S1312, sorry, 33, then sorry, this should be 232323, and then this is S1311, S1322, S1333, then S1211, S1222, S1233, and it's quite a mess, right? So you got to look at what do these terms mean. So I am going to mark some terms first. So the diagonal terms are very, very important. The next important terms are these off diagonals, and we are going to talk about the meaning. So this, and then of course plus the Aij theta minus theta naught. So this is not very troublesome, so I don't even care about it right now. Okay, so right now let us not worry about it. We'll just look at this matrix. This is a harder matrix to understand. To understand this, let us look at a particular example. So this Sij are related to measurements in various experiments.